Please use it. Spread the word. Upload pictures. If we'll get 100 followers, new followers, this evening, I'm going to do something crazy in our anniversary. Trust me, I will do it. Yeah. Who's here for the first time? Hello, hello. The rest of you, are you familiar with Sergeant JSX? You heard about this person? You heard about it. This is our YouTube channel. Currently, we are streaming live. Roman, do we stream live? Are we on air? Roman, this is Roman. This is the person who's responsible for recording and do all of this amazing stuff. Let's give Roman. How many people you've got online? Roman? Just 2. Yeah, my mother and another person. If you'd like to speak, you know, this is a community meetup. Feel free to just contact us. We can help you choose a topic. We can help you with this, all right? So step forward. Come here, talk about something. Don't be shy. Our next meetups, as usual, we already got dates in November, so save the date. It's too quick. Our next full-day workshop about clean architecture. Is there anyone here that attend the 2 hours masterclass, the community masterclass about architecture? No one? All right. Anyway, check it out. All the details within this link. 500 Tech. I want to say a few words about 500 Tech, the company where I came from. We not only organize this meetup, we've got this thing we call React Clinic. We've got some extensive experience building React applications, very complicated ones. You should check our website for the past years. And we offer 1 hour of free consulting. So if you find it relevant and interesting, we would like to meet you and review your code together, maybe share some of our experience with you. So check it out, React Clinic. Next, a big thank you to our host tonight. First. This is a gift for us, our Redux group. Thank you very much. Go ahead.
All right, hey guys, and everyone. It's such a pleasure and a privilege to have you guys here. So thank you for letting us host the meetup. I'm only going to take a couple of minutes of your time, but here's an advertisement for our hiring. So we have a ton of engineering openings in New York. We do React, we do Node, we do machine learning, we do Go, and it's all cloud native. We're actually building stuff from scratch. Just come and check it out. Come talk to me after this. And once again, thank you guys for considering us and just coming here. Thank you.
Thank you. So we've got a bunch of speakers and a few surprises, but the last round of applause is going to be to you. Yeah. All because of you. So let's get started. I'd like to invite our first speaker. Where are you? Where are you? Come on. I would introduce him, but I don't remember his name. Very good.
Hal.
Nice to meet you.
Nice to meet you.
Yeah.
Thank you.
Like.
Hello.
Oh.
High tech.
Really? Thank you. Should I go inside?
No, no.
Oh, okay. Yeah. Yeah, I think so. Can you hear me? Okay. I have like several microphones on me right now. Okay. Does this work? Okay. Hey guys, my name's Hal, and I'm going to be starting us off tonight by talking about creating consistent UI and UX at scale for large applications as well as many different applications in a single enterprise. Just a little bit about me. My name is Hal. I'm a front-end engineer at NASDAQ. And yeah. Cool. So before I go ahead into the specifics, one of the biggest things that I want to focus on tonight is going to be our specific library that we use to automate a lot of our workflow and really help us speed up the process by which we create components. But I also want to briefly touch upon the ecosystem around that we've built in order to really make the process of going from business need, user need component all the way to launch and release so that applications across the enterprise can use our library. To do that, we use various tools. The first one that I'll comment on is the name of our own, so I'll mention this various times, so I just want to introduce it right now. The name of our own component library that we use inside NASDAQ is Alfheim. And just a little bit of tidbit around that. We kind of picked the name based on, if you're familiar with it, based on Norse mythology. In Norse mythology, there are 9 different realms, and one of them is called Alfheim, and that particular realm is the one where the light elves live. And it's rumored to be, or at least it's mythologized to be, like the prettiest, most amazing realm of the 9. So we were like, if we need any North Star for a front-end application, that should probably be ours. So that's kind of the inspiration for the name right there. So with that being said, in order to get a component from essentially idea to out there in use at one of the many front-end applications that we have, the first step in the process is to manage the development process. Quite often, what you'll find is that, especially for a UI component library, there won't be a dedicated resource. You won't necessarily have a specific team working around this around the clock, but what you'll end up instead having is many application teams will require some component, and they'll contribute a little bit of their own technology, a little bit of their own expertise and time to it. But again, you won't have like a dedicated team of engineers just working around this around the clock. That also means that you probably won't have a dedicated team of designers, and you probably also won't have a dedicated group of product people. All of this means that if any one engineer wants to take this whole thing upon themselves, it might quickly get very overwhelming, and you won't actually have time to do your actual application development work. And so Productboard is a tool that we found that actually helps us quite a lot with this because it automates a lot of the steps going from prioritization all the way through backlog grooming and all the way through to delivery, essentially, letting you figure out how to prioritize your various components. Now, I'm not going to spend too much time talking about these various tools, but one thing that I would recommend you do is every single one of the tools that I'm going to mention tonight has some sort of trial version, and if you think that it might help your organization, you should absolutely go ahead and check it out, trial it, and then that's pretty much how we basically found that we liked in all of these products and how we spun up with them. The second tool is going to be Figma. So in order to go from product, or in order to go from ticketing to design, one thing that we were really thinking about was how do we make this process as seamless and as fast as possible. Now, the standard in the industry for communicating with design has historically been Sketch, as I'm sure many of you will have worked with that. The problem with Sketch historically has been that Sketch alone isn't enough. You need Sketch, and then you need InVision for some prototyping, and you'll probably need some plugins to be able to go back and forth between the two. And then after InVision, you'll need something like Zeppelin to actually communicate your designs in a developer-centric way. All of this makes the whole lifecycle confusing and difficult, and also sharing that design a difficult process. We found that Figma was great for this because you basically compress all of that into one platform. And in that single platform, what you end up doing is your designers can go ahead and design. You can comment directly in there. You can prototype flows and showcase that to business stakeholders, to your engineers, to give them a good idea, and get feedback. And most importantly, this is my favorite feature of it, it's real time and on the cloud. So as opposed to where in Sketch, for example, you might have like a sketch file, and you would have like sketchfile underscore version 3.2.9 November 29 blah blah blah, and nobody knows which version is the most up to date. On Figma, you just press a publish button, and everybody suddenly has the updated version of your designs. And you don't even need like the actual application or even a sign up. You can simply send somebody a link as if you're using Google Drive, and they can just view your Figma as long as it's shared to those that have the link. So it's really a powerful tool that we've found is very helpful to get us up to speed with communicating designs across a lot of people. The third piece of this is Alfheim scripts, which is sort of the script interface that I'm going to spend most of my time talking to as soon as I go through this whole thing. But essentially, Alfheim scripts is sort of our, you might think of it as our component creation scripting tool, similar to how, or at least similar in spirit to how Create React app has React scripts. We want to create a similar thing for component creation. And I'll get to that in more detail in just a second. The fourth piece of this, once the components are actually created, is Storybook. So now, if you've heard of Storybook, I'm sure I'm hopeful that you think it's as great as I think it is. Storybook essentially, and we'll see a quick demo of it later on, Storybook lets you visually be able to see various components in isolation. So that as soon as you create a component, you can just see it by itself without the need of, oh, I need to put this in an app and make it work and wire it up and all that stuff. It's just right there. You can also put like knobs, as the add-on that we use for it is called, put various little pieces to it that lets you toggle it on the fly, and also provide a README. And it really encapsulates your component library in a very logical, searchable way. The final piece of this that we use is Sonatype Nexus. Now, the main thing that we're trying to do at NASDAQ currently is be able to inner source our Alfheim library. Now, if you haven't heard of the term, inner source is essentially open source, but within the context of an organization. So what we want to do is, if there's a team that's working on, exchange stuff, and if there's a team working on cryptocurrency stuff, we want to make sure that all of those teams, even though they don't necessarily interact with each other directly, have access to the central repository of a component library, such that ultimately all apps coming from NASDAQ look and feel the same. They're consistent, and also that they're easy to build. Like, you don't have to create CSS from scratch every time you want to spin up a new application. You should just be worrying about the business logic and not dealing with CSS stuff. And so, as I mentioned, our big focus for tonight is going to be in Alfheim scripts. But before that, I just want to quickly get to the life cycle, the workflow specifically of how we go from component idea all the way to the component itself. So with that said, let me pull up my, my workflow. There we go. Can everybody see that? Is that decently sized? Yes? No? OK, thank you. OK. So I'll just quickly run through this, and I'll note which specific of the tools that I mentioned we use at various stages of the process. So the first thing we obviously want to do is we want to start by defining the component and understanding whether it's a valuable add to our roadmap. We want to understand if a component is something that we should prioritize and something the enterprise is likely to actually benefit from more broadly. If we do think so, we'll take that to design and figure out how best to actually approach the problem. Now, all of this, as the logo suggests, all of this is managed within Productboard, as I mentioned earlier. Once we agree on how our solution should be, our design team will create high-fidelity designs in Figma and discuss this with the various stakeholders, the engineers, and really scope out and understand how this entire process will work. And we'll kind of just go back and forth until we hammer it all down. Once the designs align with the expectations, we'll prioritize our ticket, again, managed through Productboard. Either throw it into the backlog or slot it. And then once it is slotted, create our components, tests, and README files for each component. Now, one thing that I do want to stress a little bit is, we all talk about how testing is really important, and a lot of it's usually easy to ignore because it's like you're not actually delivering anything. Your managers are never going to congratulate you for the wonderful testing suite you've written, but you still need it. And especially in the context of an inner-sourced or open-sourced application, testing is really important because you are not just creating for yourself. You're creating a component for somebody who you probably don't even know. And they need to be able to rely on this component for the next month, 3 months, 6 months, year. And so in this case, we really put a premium on making sure that there are tests and that they're all passing before actually going ahead and merging it into our library. Finally, we'll open up a pull request, review it, and if it's approved, you'll be able to share it with stakeholders visually in Storybook, as I mentioned, and share it with developers through Nexus, which kind of acts as our inner-sourced NPM, so to speak. So with that said, let's quickly go back. And yeah, and so with that, let's get to Alfheim scripts, the coding piece of this that I personally am pretty excited by. So in a typical component library, what you'll end up with is you'll end up using a lot of boilerplate. This is kind of what the file structure for a typical component that we have looks like. You'll start at the source, components, and then we have sort of a separate parent layer to group logically related things together. Then within that, you have your story files. This is kind of how you give Storybook its file so it can be displayed. And then within that, you have your component folder and all of the stuff that goes along with it. Your index, your testing files, your stories, your CSS, your README, everything. Now, the important thing here is that this boilerplate we find is necessary in order to, again, keep being able to build and maintain this library consistently. If we let everybody contribute whatever, then this would get out of hand very quickly in like a matter of a few weeks. And once we want to add new functionality or go fix bugs, then I would not be able to read somebody else's code, or it would just take me an unreasonable amount of time to do so. So for us, what we found is it's very important to enforce, to figure out a boilerplate that kind of works for you, and then enforce it moving forward. And as an extension of that, not only do you end up having a boilerplate of your folder structure, but your actual files end up having boilerplates within them too. This is like a very typical, very basic footer text component example. And what ended up happening is you basically have to import React in order for your JSX to be recognized. You have to import your styles to have styles. This is written in TypeScript, so if you're not familiar, this interface thing is essentially equivalent to your prop types. So that would usually be after, but in the case of TypeScript, it's before, and you need that in order to interface with your component. Then you actually have your component itself, and then finally we have a little bit of export magic that we do with our particular classes with our components to style them and keep everything contained. Now, as I mentioned, it's important to agree to a boilerplate. So it's important to note that not every boilerplate will work for every organization. And in fact, you should come up with your own organically. You shouldn't try to restrain yourself to a boilerplate immediately from the get-go because you don't know what you'll necessarily need. But as you move forward, you need to keep talking about, discussing it, and refining it. And also not being afraid to go back and refactor your code so that it actually makes sense moving forward. Sticking to this boilerplate makes your app more maintainable, readable, and consistent. So these are all benefits. Granted, it does add a little bit of, when we say boilerplate, we don't necessarily always think the most positive thing. So it does have a little bit of overhead to the creation of all components. But we do feel that it's important to have that consistency. Now, this made me think when we were first creating these components, after hearing all of this discussion about boilerplate, you know what you need to do, right? But it seems like so much. There's just so many components that all have to look the same. Isn't it just easier to just cut some corners every once in a while? Just skip that README file. That one's just a reusable component. Who cares? It doesn't need a README, right? And so in order to remediate that solution, we basically came up with Alfheim scripts. And Alfheim scripts, the most common use case for it that we have is creating all the boilerplate you need with just one simple command. The command to create it is just that. So I'll just walk you through it real quick. Obviously, YarnRun. Create component is the name of your command. -d is your parent level component that I mentioned, so you can group everything in there. Footer text here is just your component, and you can just have a bunch of components next to each other, and it'll create all of them in the same parent. And then these are additional flags that are basically telling the command to not create tests for render and mount on Enzyme, if you're familiar with the library. Essentially just saying, this is a very low-level component. I just want to unit test it. Don't care about integration testing, so don't give me that stuff. So with that, let's actually see it in action. So I will, hopefully, this is kind of scary because it's a live demo, but I will try to, using Alfheim scripts, create a whole new component from scratch in hopefully a relatively short amount of time. And with that, let's go ahead. So let's see. Can you see my terminal? I actually don't know how to zoom in, so if you don't see it, you know what I'm about to type because I just showed it to you on the slides. So let's do a header. Let's do YarnRun create component, and I'll put it in a test parent folder, and then I'll call the component header. And as I mentioned earlier, I don't want render or mounted tests because it's going to be a super low-level component. All right, so that ran. Cool. So we have our test, I don't know if you can see it over there. We have our test parent folder created and header inside. Additional things that were created were an index.stories.ts in order to be able to export everything that's going on inside, and a quick link to that new file right here so that Storybook is actually able to pick it up. Now, as I mentioned, here is, oh, that is tiny, so I'll just read through it. I can? Where is it? Huh? Yep. Yep. Oh, that's cool. Okay, thank you. That's nice. Okay, so here you can see our boilerplate folder structure that I mentioned earlier. We have our SCSS files, story files, test, the header, index, and README. So I'll start with the most important piece of this, obviously, your header. So here's your basic header text, right? You have all the basic stuff built into it. You have your React import, your style import, your with style class name, your interface, everything like that. Now, when we're thinking about a header, especially online, the biggest thing about headers is going to be H1, H2, H3, H4, 5, 6, right? So the div here doesn't make sense, and we also don't want to necessarily have to import all of those things one by one. So I'm just going to make a very simple interface here and give it a size prop. And the size prop is essentially going to be a number. And what I'm going to try to do, and I'm going a little bit fast here because I have a couple minutes left. I'm going to want to import that prop. And in order for React to recognize it, it has to be camel case. So let's do h size. And then this is just tag name. And so if we go to stories, we just need to export our component for Storybook to find it. And this should have led to that file being created. Okay, so now there's nothing in there, right? So that's because the story doesn't by default have any text in it. So this is the boilerplate of a story file that we're seeing. Title. There we go. The final thing we need to add here is a size knob. So let's add our knob. This essentially lets you be able to play with it right in the space that it is. So let's say size, and then let's put it to 1 by default. Whoops, that's a number. Okay, there we go. So that was it. So we can see on the right, there's your size knob. And if I did this correctly, then as I go up in numbers, it should follow H1, 2, 3, 4, 5, 6. And it seems to be. So yep, that's it. And it took us 2 minutes to make that entire component. Granted, I wasn't able to go through the testing part, but I can just show you. It's pretty much right there, and I would only need to change a couple of lines to make these tests pass. By default, when you create the test, when you create the component, all these tests are passing. And so some small tweaks will get it to where you need to go. And with that, I will just go through my last slide, which is essentially create React app-like functionality to create your whole component library, not just individuals, but start the whole library itself. Using TypeScript as a default language with default configs, custom Storybook config that works, optimized for CSS. And finally, we are working to open source this soon so that everybody can not have to deal with creating their own component libraries and just say, create component library, and then you're off to the races. And with that, you can follow me on these places. Special shout outs to Jonathan and Ron for helping me while making this thing. And feel free to follow me on Twitter for announcements related to when actually we are releasing Alfheim scripts open source. And thank you very much.
We don't have time for questions, but you're going to stick around.
Yeah.
So,
Hit me up later. Yellow shirt.
thanks. Thank you.
Yes, this one. This one.
Whoop. Hello? That work? I don't think so. Works?
Once again.
Hello? Yeah, I think it works. Yeah, cool. That's it.
So, hello everyone. My name is Matheus, and it's cool because his last slide kind of triggers my talk, so yeah. And I'm Matheus, and you can find me on social networks as Y Combinator, and Twitter, GitHub, everywhere. And I work for a company called Bacon, and we work mostly with data curation and asset curation systems, and a few experimental software like e-learning platform and those things. Most of our applications, which include React, Redux, Redux sagas, TypeScript, and Webpack. And yeah, I have to do this raise your hands things, but raise your hands here. I think most of you work with React, right? Yeah. Not most, actually. Okay. And with Redux? Redux without React. Cool. And TypeScript? Yes. Yeah, not so much. Still raising your hands. Who's got those things? Oh, you're good, guys. So yeah, these are always bad, and it's funny because those arrows goes like this in the beginning of your sprint, by mid of the week, and in the end you're just like, okay, I'm gonna send this to production, and it really scales to production. Sentry always show those guys in production, and yeah, and we've always seen people saying out there that compiled to JS languages like TypeScript and yeah, other ones are alternatives to solving these problems. And yeah, so many posts of there since TypeScript started. But so yeah, that's not new. But when I ask myself what makes people like when people don't want to adopt TypeScript in their systems, I found two reasons. The first one is that people want other compiled to JS languages like Reason, PureScript, or languages that are actually more powerful than TypeScript. And the second reason, and that's a good reason, by the way, but the second reason, which is not so good, is that people that are afraid of turning the development environment into Java development environment because of boilerplate, too many type annotations, and all those things. And I kind of disagree with that, and actually because we're afraid of losing productive, we actually lose productivity if we don't use TypeScript. And in this talk, I want to approach three parts. How to use it to typify your state of your application, your components, and last but not least, your styles. And I think I better do this by showing code that goes to production, by the way. And first, can you guys read it? I don't. Oh, not at all. Let me. Yeah, that works, I think. So, state. The first thing I like to show when it comes to typifying state is typifying your root state, the state of your store. And here's a regular Redux application, and we have this root object reducers where we have all our reducers. And by making a type-alize called root type and saying that it's just type of this object, and after saying that, iterating through it and saying that all the properties are read-only, I have this root state type. And pay attention to this guy because we are going to use this later. The second cool thing here are these two helper functions called getStates and getActions. Focus on getStates, and especially here's this for example. But what getState does is it gets a function, it just types the function it gets, saying that the parameter is going to be of type RootState. Next thing, when it comes to typifying our reducers. Reducers here are a little bit different because I'm using this lib called ReduxAct. And it kind of allows us to write reducers by piping actions. By piping actions. But what's important here is the initial state of this reducer, where I have all the parts. And the cool thing here, and the thing I'd like to pay attention is, we don't write an interface and after make all of our objects adopt this interface. We first write an object the way we think it should be written, and then we make a type for that, and this type is shared across the rest of all application. And if I go to my actions, I have the same thing. Each action, I use create action from ReduxAct, but this actually does not rely on any lib. The thing here is typifying the payload. For example, if I have set data and I have create action, I say that the payload for this action is going to be a user, or in this case, set failure, the error string. Anyways. And when it comes to our selectors, here I use that guy called RootState. And the cool thing here is because I have access, I know it's very predictable for me what I can wait from RootState and the type of this data. So mainly when we're talking about selectors, it's very important to know which kind of data we have and how to operate on this data. And being predictable, this is very important. This is not this here is a container component, and I have both map state and map dispatch props, which you guys probably see in your applications. And the cool thing here is that I use bind actions, but it doesn't matter. Is that my save prop here comes from my actions, my update data action, and when I access this in my presentational component, I know exactly what I can save. You see, I know that the payload for my actions gotta be a course. And if I try to, for example, save a string, the compiler compile is going to warn me. And last but not least, I do the same thing here in the internal state of my component. I have my initial state, and I say that this property, for example, status element, it's got to be an HTML element. And wherever I access this, I know that it's an HTML element. And if I change its type here, it's going to be shared across all the components. So I don't have to keep updating interfaces to fit changes to my objects. Talking about components, this one's cool. You know, we usually write unchanged methods for things that one-chain methods for avoiding to create many for each different property for our internal state. And we usually receive a property which tells which part of the internal state we are changing. But what if we try to change a property that is not there? Here I use this utility type called keys that comes from the library called utility types, which I'll upload later. And I say that my property has got to be one key of course, for example. And this makes me, wherever I call onChange, if I try to pass something that's not a valid property from a course, it's going to complain. Because it's got an enum that tells which properties are valid. So this helps a lot as well. Telling our components what kind of things they can render is also something that helps a lot. For example, this is a material design application I'm talking about, and we have cards. So telling what kind of data our cards can render helps a lot. So yeah, here I am saying that a card representable component is something like a course, a lesson, a user. And if I try to render something that is not this, I'll get compile time errors. And last but not least, here I have a handler method. And I get my classes that comes from material Y. Who here has already used material Y from like 5 to 10 people? That's not mine. Yeah. And you have those classes, and they are typed if you are using TypeScript. And here I can say that these classes are like inline styling, and I know exactly which ones I have. So yeah, let me give a better example for this. Here. This is my styles.ts file, and this is just like writing regular inline styling. But if I come here and my props extend with styles, and let me see. Whenever I try to access classes dot something, I know I will have autocomplete for CSS classes, and that's great. And if I write, for example, paper is no longer paper, it's pauper, and I come here and try to access this, the compiler is going to tell me that this is not valid CSS. So this is a huge gain of productivity, because if I were to write this in regular JavaScript and try to access a property that does not exist, I would just discover in production figure this out in production that my styles aren't being rendered, and this really sucks. There's also some extra stuff. Libs like ReactNYC and type safe actions do the very same thing of typifying actions that I showed with Redux Act. Redux Act does this great, and does the same with reduces. Utility types brings in a huge set of utility types that come from Flow. Who's here heard of Flow? Yeah. Who here uses Flow? Thank you. Yeah, you know how utility types are very helpful. And there's so many stuff when it comes to enhancing reactive patterns like hooks and stateful components and all kind of patterns, enhancing them with TypeScript. There's this very good post by Martin Haldun about this. If you want to ping me, I got stickers. So if and yes, that's it. There's so many other things, but no time. Thank you. That's it. I think it's time for questions. Yeah, I kind of rushed it a little. Huh?
Can you repeat just the question?
I come from Brazil and Northeastern, and I'm spending a few weeks here in New York.
Are you going to stick around?
I don't even know.
Anyone else?
Okay. 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 Thank you.
Where's the cable? Mana? Mana? Already on. I can't hear you. Are you ready for our traditional quiz? So put your phones out of your pockets and get ready. If this is your first time, go to Kahoot.com and IT, Kahoot IT, all right? Go to Kahoot IT and wait a second. Yep. Put this game pin inside. Where's the music? Should be music. No music. Wait a second. What's the name of?
It's not going to be fun without the music.
No, it's not going to be fun without the music. It's going to be boring. You can use your real name as usual or a fake name. We don't care. We don't have any privacy policy for the quiz, just as a reminder. So while you're connecting to this app, we're pulling all of your private data from your phones. And we will share it with everyone for free. Is that the music? Yeah. They've got like a Halloween thing. Spooky. Oh, we've got a pizza. Yeah. Capital one too. All right, 60 people. We're going to wait a little bit more. Oh, yeah. Getting creative. That's important. All right. Just as a reminder, our quiz does not include any prizes at all. So we don't have really any real reason to taking a part of it. Oh, actually. Is there anyone who's still trying to connect? Please raise your hand. Take your hands down. Raise your hand again, please. All right, take it down. Last time? No, we got it. All right. Yeah, we're going to start without you. If you don't know the rules, you're going to see a question on the screen. You're going to get 20 seconds to choose the right answer. Please be honest. This quiz helps us learn more about you, so we can take this information and do absolutely nothing with it. All right. Ready? First one. Let's go. How well do you know React? This is not part of the soundtrack. We got some technical issues. The answers. Oh. So it's like the How many invisible mean React development machines are here? Alright. Where are all the mean React development machines? Raise your hand. Raise your hand. Yeah, raise your hand. Let anyone else see the monsters within us. Are you looking for a job? Be honest, it might help you. Both capital 1 and capital 2 probably hiring. Yep. If you live with your mother but you still need a job, that's a special case. Please contact one of the organizers later. Who's living with his mother? I know you're shy, huh? Who's hiring? Raise your hand. All the job seekers, all right? Look at those people and please attack them during the break. This is your chance. All right, let's see how about general knowledge. Who's the person in this picture? Looks familiar. Yeah, which movie? How well do you know your community? And this is, of course, Vin Diesel. Who said Vin Diesel? Raise your hand. All right, I've got a prize for you. You want a postcard? Take it. Thanks. It's nothing. It's just a postcard. Yeah. Not gonna help you. But hey, you won. Yeah. Yeah. You can't get a postcard. Sorry. Yeah. All right. I'm a front-end developer just because. Oh, what's happened? It's gonna blow up. You gotta do something. Maybe it's VS Code. No, I know what it is. Yeah. Who failed the job interview at Starbucks? We've got 16. Raise your hand. Yeah, don't be shy. Yeah. Oh, wow, they've got really tough interviews. Someone told me. How many meetups a month do you attend? Are you a community person? I don't have anything smart to say about this. Just useful information. How many hopeless? 31 meetups a month. Raise your hand. Raise your hand. There is no 31 meetups a month. Where are you going at night? What would you do for the ReactNYC community? What can you do for us? Let's see. How much do you love your community? I will do anything for the community. Almost anything. Just to be clear, I'm talking about my mother. Trying to do something good for the community. Who clicked the blue button? Come on. All right, you can be anonymous. Talk with me later, please. What else should we do at ReactNYC? Which kind of talks? Which kind of topics? What do you want to learn about? Help us craft the knowledge. Choose the best talks out there. Bring you the top speakers. No, I'm kidding. That's interesting. All right. You should check out our workshop anyway, but we're going to hear you. And we're going to try to give you some more useful content. How big is your front-end team? If you're like not a job seeker and you've got a team and you know how to do front-end. So if you like got all of this stuff together. Just me and my horse, yeah? How many here, people here live in Jersey? No one? Just me and my horse, which is fine. We are an inclusive community, right? We accept everyone. What do you do in your free time? Let's get to know each other. The picture got nothing to do with the question. Who's the person in the picture? Is this Y0l? How many people dress like Michael Jackson? We've got 6 of them. You don't have to raise your hand, just keep it to yourself. That's fine. You can do whatever you like with your free time. All right, last questions. Why do you come here? Honest question. You lost it. It was your chance. Which code editor do you use? Last question. The final one. Are you a VS Code person? Are you a professional developer who uses WebStorm? Do you use Atom because you're a hipster or something? Or are you Irish, which is totally fine? I'm part Irish myself. You can never tell, but I can play this flute. All right, how many Irish? Raise your hand. Woo! You're not Irish. Come on. What? You are? No, not you. Okay. All right, thank you very much. So we're gonna take a short break. I'm gonna put a stopwatch right here. After it, we've got 2 more talks. One of them with Y0l. So, especially for the people who that's their social life. All right, where is our next speaker?
He's right there.
Where are you?
Right here.
Raise your laptop. Come on. Woo!
One, two, 1, 2. We're all good? Okay. So welcome back from your break. My name is Michael Garrigan. I'm going to talk about D3. It's something that I've kind of been geeking out for the past couple months, and when I realized I primarily do React. So when I started looking at, okay, so I want to make a chart. I want to incorporate this into my components. What I started to realize was it wasn't just plunking in a chunk of code, because for the couple reasons that we'll go over, React just doesn't play so well with D3 sometimes. So we're going to talk about the reasons why some of that is, and then I'm going to step through an example, and we'll see that. So if you're not, well, before we start this, if you're not familiar with D3, it's essentially a data visualization library. So this is something that if you want to build charts, graphs, all sorts of these things, this library is primary. I would venture to say it's probably the most popular library out there for doing this sort of work. And there's been a lot of smart people over the years that have put into this. And it's really just a tremendous tool. So some of the issues that I found going in is maybe like a lot of people, when you go in, I say, okay, I want a radial type chart. or I want something that has bubbles that all kind of cluster into the center. And so you go out to the internet and you find an example. And the great thing about D3 is there's just tons of examples out there. So you can go out there and anything you could think of has already been written and is out there, and you can just kind of grab that code, tweak it, change a couple things, and it's really nice. The downside is a lot of this is in version 3. There seems to be a huge spike in all these examples that are written in version 3. Now D3 is now on version 5.7. And when D3 got to version 4, there was quite a lot of breaking changes, or the API changed considerably. And so it's actually kind of interesting. When version 4 came around, there was as many commits in version 4 as there was of all of D3 before that. And so things changed enough where it's difficult, if you're stepping in new, trying to figure out how the API is different and why these examples from 3 aren't working. The second part is, do you want to write it yourself? Because there's a ton of great libraries that are already out there for React to do basic type chart stuff. And I would honestly just recommend, if you just want basic bar charts, pie charts, radial type things, just go to one of those libraries. They're already done. You can kind of just, wrappers are already made for you. You can just plug stuff in, and it's super easy. But what I found is every time I went to one of those libraries where everything was already done, there was always 5 things that I wanted to do beyond that weren't included in that API that I could do. So I ended up having to dig into the code anyway, or try to change that library. And so, and then the last item is really the DOM, because D3 wants to control how the elements are displayed on your page. And React, as we know, has its virtual DOM, and it wants to control the DOM. So it comes down to a point of how are we going to divvy this up, and I'll kind of walk through what I do. So as I mentioned before, there's a ton of great libraries that are out there, and if you need simple stuff, I would suggest just going to some of these, you plug it in, and it's super easy. When we get to examples, you get things like this, just pages of stuff with maps that are beautiful, and brushes, and all these types of charts that you can really just open these up, grab that code, or just open them up and scan through them for inspiration, not what you want. So it's one of the nice things on my end when you go into, you have an idea that you want to display something, you want to have some sort of a visualization, a dashboard item, and you can go on here and just surf through items that you never would have thought of yourself. So there's a lot of involvement in the community. So when I was referencing to version 4, one of the biggest items was everything went down to modules. So normally you would say import D3 from D3, and that's how you would call all of your code. So now it's broken out into like 30 or 32 different modules. So everything is in its own chunk, and now you say import scale linear from D3 scale. And so what this means, and really the nice thing about it for the developers of the API, is they can iterate much quicker. Rather than updating the whole library, they can just take one of these components, add a couple items, release that, and do its own version, and everything is, and then also as you're including this, D3 is always known to be a very a heavy API. So it was, just the size of it was very big. Where the nice thing is you can just ask for the 1/5 of the library that you actually want to use, and just include that into your component. So this next one highlights a couple of these groups, and the best I can tell, about 1/3 of these modules actually want control over the DOM. So what that means is the rest of these guys, they all are pretty much just math-based functions for converting essentially data from maybe whatever initial value you have, converts it over to some plotting points on where it's going to actually go in your graph. A lot of these things can do functionality that like something like an underscore or a Lodash. They're kind of like helper functions. So a lot of these guys you can use right out of the box. You don't have to pay any mind to how you're going to divvy that up between React and D3. Whereas these ones that are green, they really want control of the DOM. So when we start working with those guys, then that's when we have to start thinking about divvying these guys up. So the great thing is we know about React is it has this diffing algorithm that goes through and creates a tree of all of our elements on there. And it's just very quick, it's very optimized to see what's different in the DOM, update those things. D3 has its own system for updating the DOM, and it's essentially, it looks at whatever data. You have an array of data that comes in. If we have 2 more elements in that array, now we're going to add a couple more on. So essentially it's just monitoring the data length and then updating it from there. So I like to pretty much give everything that's DOM stuff over to React and allow D3 to pretty much just be in charge of math, doing computations. And you have, like I said, there's a lot of people, as I've been digging through the library over the past month through D3, I really just appreciate how much work has gone into a lot of these guys that are cartographers and people that are doing very high-level geometry that have put a lot of really amazing equations into here that calculate how to translate what you want and show a map of Pennsylvania, per se, how to translate that down into SVG and post all those points on there for you. So the example I want to step through is, if you've done any looking around, this is a very entry-level one. It's a basic bar chart. And what it's doing is it's just looking at the letters of the alphabet and ranking them based on their percentage of the time that it's used. So the letter A gets used 8% of the time when you take a big cross-section of writings in the English language. So essentially this chart has 3 chunks to it. Really, we have an x-axis along the bottom, we have a y-axis going up the side, and then we have this middle chunk, which is just a bunch of rectangles going across. So when I'm taking a chart and I want to translate it into a React component, I tend to just look at it from this value and just pick out its main chunks and start there. The beautiful thing of what D3 is doing is it's writing pretty much everything for us in SVG. So SVG is a scalable vector graphics, which is an XML based format. But the nice thing is, what we have available is we can open up the Chrome DevTools, and we can just inspect all this stuff. So we see this massive garble of numbers and letters and G tags and all these sorts of things. But what's nice is these first 2 lines are showing us x-axis, y-axis, and then rectangles. Just go down the line to all those blue bars that we saw going across. And so what I like to do is I'm translating a chart into a React component is essentially I'm putting the return tag above that SVG And it's just starting to visualize what pieces need to go in the final product. And it kind of just allows you to open up the box and see how this thing is made and how you can start to manipulate it. So the original example, this was a version 3 example. So this is the original D3 example. And you can see, or probably not read it very well, but that's not too important. The important thing is it's only really like 30 lines of code, maybe 40 lines of code. So it's a pretty compact thing. So what's happening is we're declaring some variables on the top about the size of things. We're doing some stuff with the x-axis. And then you can see we have this section where it says d3.select body. And if you're not familiar with D3, you'll see very quickly this just mimics or looks very much like jQuery. So we're pretty much saying, hey, select the body tag and append an SVG element onto that body tag, and then give it a width element and a height element, and then append some more stuff onto it. And that's pretty much how D3 is working. It's just saying, okay, take this element, add some other chunks into it, and I'll show you in a little bit how we are going to move that in. But essentially, we're going to move all that stuff into our return statement in our React component. As it goes down a little bit further, it's pulling in the data about the middle point. Then it goes into a bunch more jQuery stuff, and then it's doing a little bit of type work. So hopefully you guys can, these next couple slides are all going to follow the same format. The original slice up top, and then the way that I translated it to the React component down below. So this first one, it was just our variable declaration. So this is a functional component, and we're bringing in as props dimension and data. Because React will know what to do if this chart ever resizes. What I like to do is I just put listeners on the parent element with their sizes and then pass that into the chart that I want to do. So anytime, if that was in a flexbox component, anytime that's moving, my whole chart is now coming down and growing back out. Then, of course, the data itself is coming in as a prop. So here we just have the ability that if you had a button that you could click on or part of your website, change that data around for a different view, pretty much that would enter in and update the chart as well. And underneath it, dimensions is coming in as an object, so it's just destructuring the variables off of that. This next piece is going to be a really good example on switching from D3, or I should say version 3 to the updated version. So if you see, we have scale.ordinal. And when you come down, the actual translation, when you start digging in the library, is you have scale band, camel cased, all one word. And you have range round on the bottom, whereas above you have range round bands. So you'll start to see when you start moving these old examples over to the new API, that you have things that look kind of similar, but they're just different enough that you don't quite know where to go. And then also what makes it a little bit confusing is all the documentation is also broken out into those 31 different modules. So sometimes you may jump into a module to look for the documentation for one of these items, and it's not in the one that you guessed it would have been in. So it's just something to keep in mind. And again, these are just defining scales. And scales in D3 are pretty interesting, where essentially you can have an arbitrary piece of data come down. It'll hit a range, which we'll call that our domain. So a piece of data comes down, it falls into that range, and then that range is mapped to the one below it. And essentially that's another range of values. And so it maps it directly to that, and then what it spits you out is the coordinates on your SVG and where it should go. And these are super helpful. There's like maybe 15 different varieties of these scales. And if you get into it, you'll see how useful they are for all sorts of things. Okay, so here's the start of the original. The D3 is trying to do some jQuery type stuff, grabbing the body, chucking an SVG into it. And so here I'm just defining it straight into the return statement. An SVG with the width and the height, so it'll change automatically. And then just starting to define my elements right there in the return. We'll go on a little bit further. This, you see the original example is a TSV. It's bringing in its data from a tab separated values type system. And mine, I converted it over to a comma separated values. But I just will point out that the nice thing that D3 can do for you is that in this DSV module, it'll give you the opportunity to define your own, it stands for delimiter separated values. And what this will do for you is you could just put a money sign symbol in between your values and tell it that that's how the data is going to come in, and it'll read all that correctly for you. So yeah, so this is essentially just pulling in the data into our component. Above, this is our axes for our X and Y axes that go up and down. And again, here I'll just point out the code necessarily is not too important, but I just want to point out the difference in the API from version 3. If you look at the top, you have this SVG, .axis, .scale, .orient. And in the new one, the new version, we have this axis bottom camel case. So it's similar, but it's different enough that it kind of makes you turn your head a little bit. I guess the other interesting thing here too is, so here I'm looking at this group tag, and I'm putting a ref onto it, and then I have this a function in there, and it's taking this node. Then it is allowing D3 to do its jQuery thing, and it's saying select that item and then call it with this function, and that's going to generate all those little tick marks and all the A, B, C, D all along the bottom. So those are the access points, and then so now we're on to the actual bars, the blue bars that we're all going across. And this, I'm sure everybody has seen something like this. We just have an array of data. And just one thing on D3 tends to like its data as an array of objects. So it's how it likes to see its data coming in. So we have this array, we're mapping over it, and we're returning some JSX with this rectangle with all the pieces on there. So that's how we're getting all our bars in there. And this is super small. Can't see it, but the interesting thing is beyond the very top declaration, this is the finished, everything in that React component to make that exact same example. What's interesting here is the proportions. So at the very top, I'm just asking for a couple different modules out of the library. I only have like 8 lines of actual code in there before that return statement, and like 80% of it is all just in that return, and it's happening there. And that's pretty much it. We can open it up, take a couple questions.
Thank you very much.
Yeah?
We don't have any time for questions.
Oh,
right now.
okay.
We got another talk, but stick around.
Yeah.
People want to know more about SVG. Speak up, please. All right, our last speaker.
What? Yeah. I mean, there's no emoji, but I mean, what are you gonna do? Oh boy. Here we go.
Good.
Yeah. I really don't know why this doesn't have fucking emoji. No. Yes. Yeah, but there's no emoji. It's the weirdest thing. See? There's like a little piece of emoji. Am I really going to give a presentation without fucking emoji? It's fine. Is this on? Yeah? Yeah? Hey! Hi, New York. What up? This presentation had emoji. For some reason, it's not rendering the emoji. You can see like the top of the flames up there, but it's not like, I always see everybody have these like tight ass presentations with emoji and shit. And I usually use memes, but I decided to use emoji this time and it fucked me over, but whatever. We're chilling. Hi, I'm Ken. My name's Ken Wheeler. It's a gun, I'm not pointing. It's not a gun, it's a hand, but you know, whatever, I'm chilling. Ooh, there's an emoji. Yeah, so I'm Ken Wheeler on Twitter. There's my phone number for your mom. There's my there's my email address if you want a job. I work at this place that I'm not allowed to say that I work at, but it's tight, so you should holler because we're hiring. And I recently released an album called Love Songs for Your Mother. You should check it out. It's on Spotify and iTunes, your mom's iPod. And today we're going to talk about making React fast. And that's not to really imply that the shit isn't fast in the first place. But from time to time, you'll encounter, performance issues. And I certainly have encountered performance issues. So I'd like to share how to resolve them and also show some hot new stuff tonight that people may not have seen before. So the first, anytime you bring up performance in the context of React, you always have that person who's whining and bitching about premature optimization. They're like, it's fast enough. And sure, it is fast enough. Not that it's not that you don't have a perf problem, but that a lot of the time the shit that you're building doesn't necessarily surface it, right? So you might be writing, not necessarily performant code, but nobody knows because you're not doing ambitious enough of shit for it to actually surface, which is fine. But, at a certain scale, you're like, what's going on? It becomes super apparent really quick. You don't know you have a perf problem until you have a perf problem. So, do you need to optimize? Sure you do. You don't need to do it super granularly, but, there's certain things that you can do while you're coding and make a habit of that'll, kind of make it a little bit easier moving forward, right? So, say you do have a perf problem, right? Say you're sitting here, your boss says, oh, build this thing. And then, you're like, yeah, they made this crazy thing that they wanted to work. And then they get it and they're like, it's slow, You're like, you fucking kidding me? But like, you have a perf problem, it's slow. It says perceived slowness. So what's gonna make it slow, right? Let's talk about why shit is slow. So the first thing is slow loading, which is load perf. Right? This is like your initial load. It's slow to get it going, right? That's not really what I'm talking about tonight, but I'm going to run through it for a second, right? That's like bundle sizes. If you have a huge bundle, if you're not code splitting, right? So if you're not splitting your code out so that it can be loaded asynchronously on demand, so you're not just serving up a la carte code slices, right? And parsing. Right? So anytime you have a big bundle
or anything like that. Not only is it the download from the network, but it's the parsing before the browser can even evaluate it that adds to that slow startup. But that shit is, generally speaking, pretty easy to get around, right? I mean, all you can really do is use like Webpack dynamic imports, and you're pretty good to go in that respect. You know, you watch things, and you set up little fancy Webpack to drop the locales at a moment or what have you. You know, there's a couple little tricks, but you know, it's the sort of thing where at like a build level, right? You're going to solve that, and then you know maybe at like your routing level, you're going to solve that. You can get a little bit more granular. But what I'm going to talk about is runtime perf, and I am going to live code my ass off, and I am going to fuck it up, and I'm sorry. Also, Michael Chiklis, fuck you. But whatever. All right. So runtime perf, right? So what's that? That's like CPU bound ops, right? So if you have shit going on, like if you're crunching numbers, being all fancy, you know, doing any kind of CPU sensitive things, right? JavaScript's single threaded, the browser's single threaded, generally speaking. So you know you're gonna, you know, after that load, right? Most of the time people can wait for the load. I mean, they went through Flash. They can deal with the loading spinner. But when it's loaded, people get really mad when the shit doesn't run after that, when you start getting problems there, right? So one of those things is not using workers, right? So if you have some data intensive stuff, a lot of the time you can offload that to a worker, right, which operates independently of the main thread and kind of just post messages back to business, and you're good to go. But the biggest thing is wasted renders. So this is kind of React specific, because in React what you're doing is you're building up this entire tree of components, you know, all the way down, this big gnarly tree. And each one of those components has a component wrapper, and those component wrappers have a cost. Your render function has a cost. All of this has a cost. And when you're doing one pass, dude, do you see this beautiful trash can icon that we're only seeing a quarter of? This is killing me right now. I digress. But yeah, when you run through that tree, that's like O to the component, right? So if you have however many components, you know, you have that component overhead, and there's not really a way of getting around that other than making them not render, right? So what causes an update in React? I feel like a lot of people that I talk to are kind of, you know, I guess they don't know about this. But let's do some live coding, right? I'm gonna go and show the causes of updates. Does anybody know what makes things update? Yeah, fucking everything. You know, a lot of people have this like idea in their head, like, oh, React's smart, man. You know, if you pass it the same props, man, it's not going to update that. No, fuck that. No, it updates everything, all the time. Oh, you have to tell it not to update shit, right? Most of the time, you know, you're making, you know, Johnny To Do app. It's not a problem, right? Everything updates. It's not a big deal, right? Then you start to do some animation, and you're like, oh, fuck, dude, this is fucked up, right? It's like, it's because everything updates all the time. And you have to grab hold of that and figure out what's going on there, right? So let's demo. All right, and here's where I'm going to live code and destroy everything. Okay. So I made a really, it's not even an app, it's just kind of like some shitty markup to show what I'm doing here. So what do we got here, right? So whoop. It's kind of big. Jesus, fucking. It's such a huge gutter from pumping it up. Whatever. We import our React from React. Can everyone see the screen okay? It's good size? Yeah? Okay. Yeah, so here we have a functional component for our app. In here, we return this business. If you're not familiar with this shit, this is a fragment. If I didn't have this in here, it would be like, you can't render top level adjacent. But now when they added this thing, you can also do, you know, React.fragment. Right, it's just kind of like some thing that you can wrap around things to get it to shut up instead of like an extra div. I digress. We have two children here. We have a class-based child. Class child extends React component, and we have class function child. Right, and this is a stateless functional component here. In each one of these, right, it's going to take a name prop, right, which is a string. It's going to render it with a p tag. And then when it renders, it's going to console log either class rendered or function rendered. Fair enough, right? So we refresh it, and if we look in our console, class rendered, function rendered, right? That's one update. Why? Because nothing's actually updating. So let's update some stuff. So I am going to update some things up in our app by adding some state and causing some stateful updates. But I'm going to do this in a special way. Can I see a show of hands who watched ReactConf this morning? OK. So they released a new thing today, and I'm going to show you it. It's called hooks. And this shit is crazy. So you might be used to doing like state in class components, right? But in like functional components, you've been like, I guess they're stateless functional components. They're stateless no longer, and I'll show you why. So here, I'm going to import these things called hooks, right? So there's a number of different hooks, but I'm going to get the state one. It's called useState, right? So our app function right here, this is a functional component. No lifecycle methods on the class because there is no class because it's a function. So how does this work, right? So if we want to add state to this, what we're going to do is I'm going to say const, right? And then I'm going to say count, and I'm going to say update count equals use state 1. I'm not starting with 0, right? So this shit looks crazy. I'm going to explain what exactly is happening here right now. So useState is a function hook. The first argument here is your initial state. What that does is that returns an array. What we're doing right here, this doesn't have to be anything. This could be butts and poop. Nobody cares. It's array destructuring, right? Right here, you're just saying these array indexes are going to be known as this shit moving forward, right? So I'm saying it's count and update count. Essentially, what it is state and set state. That's how you can think of the useState hook. Now you might be asking yourself, how does this work? How does this right here give you state inside of a function component? I have no idea. I looked at the source. I have no idea how they do this shit. I really don't. But it works. It's crazy. So in order to have that state, right, we're going to have to, I guess, render it out, right? So let's do a P, and let's say count right here, and then let's put in a button, right? And I'm going to say button type equals button because I'm not an animal, and then on click equals, right? Yeah, we're going to go ahead and use this shit right in here in a perf talk. Nice job, Ken Wheeler. And then in here, I can say update count, right? And you can just update count with a value, or if you nasty, you can use the previous state here. I can say prev state, and then we'll return prev state plus 1, right? I'll hit save. Are you fucking kidding me? Oh, yeah, I'm an idiot. You rely on that self-closing, it just bites you. Okay. Yeah, so we have a button right here, and magically, this shit adds state. Isn't that crazy? Yeah, so there's a couple other things. Before I get to this perf thing, I'm just going to show this for just one more second because, it's so crazy. So there's another one called, there's actually a couple of these things, right? But this thing's called useEffect. This is also bananas, right? So useEffect, you give an argument, which is a function, right? And this is essentially component did mount. Right? So I could say like mounted right here. So see this? Mounted got returned down there. And the craziest thing is you can do multiple of these. Right? So you can use many states, so hooks you can go crazy with and just compose them together and make new hooks. It's bananas. Component will unmount, you ask? You want to dispose of a subscription? You just return a function from useEffect. I'm not going to unmount this shit, so you're not going to see the log, but that's how you do it. I'm just saying. Okay. So let's get back to what we were originally talking about. All right, we're getting all tangential and shit. So right, we have the class child, we have the function child, right? Both of which are regular S components. Up here we have a button. Right, we're going to change our state. Holy mackerel! Do you see this? Every single time that we change this, these child components got re-rendered every single time because React is not optimized for that out of the box. All right? So what can we do? Right now, it looks like, so just to make something clear for a second, you should strive to have your props be referentially equal because it'll save you a lot of time and calculation. And I'll show you what I mean. So for our class child here, class child extends React component. I can just say extends pure component. And what that does is says if all the props, even object props at a shallow level, are referentially equal, don't re-update. Same thing with state and context. So if I hit state here and then hit increment, all you're seeing now is the function getting re-rendered, right? So I've blocked class child from being reevaluated, right? Because name is referentially equal. But function, function you can't optimize for, right? Wrong. Wow. With React 16.6, they introduced this shit called memo. It was originally called pure, like pure component, but they call it memo now. It's a long, stupid Twitter debate. But I can say const function child equals memo, and then kind of just come over here and do some shenanigans. And this right here, this memo shit, right, does essentially what that does. Right? It says, if the props that are coming in are referentially equal, it's not going to update. We're going to save a bunch of time. That's crazy shit, right? So this works out pretty good if you don't have any shitty anti-patterns. So I'm going to show you some shitty anti-patterns for a minute as to what could fuck this up. So if I come here and I say like 2, right? 2 is fine, right? Numbers are referentially equal. It's okay. Strings are referentially equal. You know what's not doing shit like this? In order to do this, I'm going to have to two-string this or something. But you see this right here? Uh-oh. Suddenly our class is re-rendering like crazy. Why is that? Nobody? That's right. When you do this, you're creating a new array every single time, which is bananas. So if you wanted to fix something like this, right, let's call this ARR, right? And I can come up here, right? I could say const ARR equals this, right? Suddenly, it's referentially equal again. The same applies to objects, because I mean, who doesn't love to do this shit? Don't do it. Don't do it. It'll fuck your perf up. Promise. I'm going to check my iPhone notes because I feel like there was another thing I wanted to show here before I got into the bananas example. I know we're getting a little low on time here. That's right. Okay, so another one you might run into, which is probably the most common, it's not only arrays, it's not only objects, but it's these rascals. Uh-oh. Uh-oh. All right, so if we came here and we did a function, right? If you put an anonymous function in there, right, it creates a new anonymous function every single time. Not referentially equal. Now that is the sort of thing where I've gotten pushback before. I've been on teams with people who didn't understand entirely how this worked, right? They're like, but hey, I have to do this, right? A good example, which I'll show really quickly, kind of independent of this demo, is say let's just get rid of all this bullshit for a second. It's irrelevant. Say we're here, right? And we're saying, this dot posts dot map, right? Post, right? Then we come down here, and we return, I don't know, fucking li. I'll put the keys. Shut up. I know. I don't even know why I'm putting the key. I'm never going to get an error because I'm not going to evaluate this code. I'm just showing you, but I don't fucking care. Post.body. Okay. So you might say something like, I don't know, on click, you want to remove it, right? You're going to say like this.remove.bind, post.id, or null post.id, this post.id. Can I see a show of hands who's done this before? Me too. I do shit all the time. But you might ask, how do you get rid of this, right? And like a lot of people think like the whole bind thing's gross, so they're like, all right, I got a great idea. Here we go. We'll just make it an anonymous function, and then we'll call this shit. Fucking tricky over here, super slick. No, because this does the same thing performance-wise, right? You're still creating a new one. In my experience, doing these shenanigans, the best thing to do, right, would be create a new component, right? So if you want to do this for perf, generally speaking, what you would do is posts, right? You're going to return a post component here, right? You're going to say, onClick is this dot onClick, and then whatever value you want it to do back, like ID is post.id or something like that, right? And then up here, right, we just create a freshie class post extends React dot component. I don't care that I spelled component wrong. I don't give a fuck. Li on click equals this dot handle click. Or Airbnb is going to yell at me. Here we have handle click, right? And then what you do in here is where the magic happens. You say this dot props dot on click, and then you call it with this dot props dot ID, right? You just pass it down a level, and it works just fine. So that's a good way around that if you find yourself in a performance-sensitive situation. If you're not in a performance-sensitive situation, it's fine. Nobody cares. So let's say you do have a perf problem, or you think you have a perf problem. I want to just spend the next couple minutes refactoring some code and using the dev tools to identify where the problems lie, right? So let's look at some crazy shit, okay? So let's just take this on its face for a second here. All right, we've got an app, all right, and it's got a state called data, all right? So it's going to get its data from props initially, right? We're going to generate this data. Essentially what we have here is 500 squares with a shit ton of things going on here, right? So you have a high, low, open, and close. I work in fintech now, I'm sorry. And you have an outline here on these things, right? So we have a set interval here that's going to update the data, right? And what that's going to do is it's going to pick randomly 20 of these squares to update at a time for each one of these iterations, and it's going to generate new values for them randomly, and then it's just going to update it, right? This is crazy town, but it's a lot of like super high frequency updates. And in here, right, we say if there is data, we do our grid with the data, right? If we look down here, right, we have our grid. This is the grid right here. You're going to say this.props.data.map, right? We're going to destructure high, low, open, close, and highlight, and then we're going to pass them down onto the grid cell, okay? We're not in bad shape right now. This shit is not slow. Why it's not slow? Actually, I don't know why it's not slow, to be honest. I mean, it's pretty fucking slow, but it's not like crazily slow. But I'll show you how I've already set this up for success without premature optimization. What I've done here is, you ever see anybody do this? You see that stuff? Yeah, if you see somebody do that, punch them in the chest. That's bullshit. Don't do that. You know what else you shouldn't do? You shouldn't pass as much as you can. Don't pass big ass objects or arrays of shit onto components. Just create more components and then pass them as their individual things. The reason I'm able to optimize this the way that I am is because what I'm passing here are floats and booleans, right? Those things, when they're in the render process, right, and this render process is going to do an evaluation of whether it should update or not, it says, hey, is this float equal to this float? And that's super cheap, as opposed to some should component update method where you're going to sit there and like loop through an object and you're like, does this array full of objects, does one of these objects in the array have an ID that's equal to my shit? And then it's too much. If you just add more components and pass the things down as things that are referentially equal, what you're able to do is you're able to do cheap comparisons, which means you're easily able to know what should update or not, right? So believe it or not, this might look like it's going pretty fast, but it's not. It's going slow as shit. And I'm going to show you what I mean. So if we go to our perf tab here in DevTools, and we hit record. Okay. Okay. Wow. Oh, hey now, not you. You. All right. So you come here. I'm just going to drag this down for a second. Right. How the fuck do I get down? Okay. If I drag down, 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 over to here. Right. You see here in the user timing right here, right? What we have in user timing, we have a React tree, our app, our grid. Anything you see with this little React logo is one of your React components. And you can see how much of them are updating, right? And how long it took for them to update. If you want to see what is actually going on behind the scenes, you can come down to the main here, right? And you can come in here, it's component set state and queue set state, right? With the new fiber architecture, what's happening here is the work is getting split into fibers, which is individual units of work. You're doing perform units of work. You're gonna come down here, right? It's doing all these little begin mark, update, fiber mark bullshit. You know, don't even worry about that. What you really want to focus on is right here and what's going on, right? So let's pull this down for a moment, right? We have grid cells right here. These are grid cells. I don't know if you, wait, where the fuck did that go? There you are. Oh, you disappeared. So I'm going to just go ahead and take pure component off for a second, right? You know what? Let me just close this so you can see what I'm talking about here. All right. I don't know the refresh rate on here. See this? This is with pure component. This is where it's doing the checking. And that's where it's not. Do you see the difference? How big of a difference is it? That's like 30 frames per second in difference, right? If we go and we look at our performance here, you'll be able to see drastically different. No. Code Sandbox updates automatically when you're typing and shit. This fucking rendering tab's killing me. Yeah, so if we zoom out for a second, this is our update, and you're seeing it's taken way longer. Not only that, if you look in here, look at all this crazy shit. Look at all this. What it is it's every single cell is updating, right? Because that's how React rolls by default. Remember before how I was talking about how you have that inherent component overhead regardless? If you add that many cells, it doesn't matter if you're doing pure or not. So I add pure, and it's a lot faster, right? Even with the same amount being updated, you still have to check against them, right? So if I come up here to my generator, where I'm initially generating them, and I switch that to, say, 2,000, look how much slower that is, right? That's kind of crazy, right? So how can we make this faster right now? Now we're going to get into the performance micro optimization. So let's take a look at what's going on here, right? So we have a grid cell. Does anybody see the one perf problem so far? Yeah, the style right there. Okay, so we have this style, which is a problem. All right, we could take it out, and let's just call it no, stop it. This dot props dot highlight, right? Now it's going to complain because highlight here, right? I'll just have the initial one from the data return nothing. And then here we have our random generation method. We're going to take u, and we're going to stick u where the prop was. So it generates it on the data, right? And now it looks like it's sped up a little bit, right? We get, no, fucking stop. Right, so we got a little bit of speed there. There's a couple other things that we can do here. I'm probably running a little low on time, generally speaking. Here we have this, right? This is an anonymous function, right, which is getting called a billion times per second. If we wanted, I'll show you something crazy. So here we're doing set interval, which is bullshit. We shouldn't be updating data like that, especially as it translates to UI. Anything that ends up in the UI, right, we should use request animation frame, right? Take this out, this dot update data. Here, we're gonna, there's our set state. And down here, we're gonna request animation frame, this dot update data, you guessed it. So now it's not gonna try to do it that many times, right? Now it's just gonna do it when it can do it. And it can do it pretty fast right now. But I'll show you something interesting too. There's some things that are not React, or not what you would think in this scenario would make shit faster, but it does. The first thing that I'm going to show. What's the problem here? Why are you refreshing on me? Okay. If I go to styles here, right? Check this out. So the grid cells right here, they have a width. They have a calc on the width and the CSS. A lot of this stuff is CSS performance as well when you're doing rapid amounts of paints. You see how much faster that got? That's like, I profiled it before, it's like 8 frames per second that you gain from not using a calc, using a regular percentage value. I think it's even faster if I do it as a px value, but you probably can't see it. But let's just say it's that. What's even more interesting is if you're doing paints, if you do them over a smaller area, like if you just update cells in a smaller area, it's a shit ton faster than if you do the whole thing. So if I come here, here's our update method, right? So let's update 20 cells over the first 50, right? Look at that. Insanely faster, right? If you're only updating cells that are in this first 50, right? Let's say we wanted to update this whole grid and still have this kind of performance. What do you do? Windowing. Is anybody familiar with windowing or React virtualized? Yeah. So what it'll do is there's libraries where if you had a list, and this is generally a list. It's a table, but it's a list. What it'll do is it doesn't render shit that's not on the screen, right? So if you have a list of 50,000 things, and at any given time you're only showing 25, it only renders 25. So then if you're doing data updates to UI, you can get this kind of speed. I don't know why anybody on Earth would need this kind of speed, but if you did, this is how you would do it. You would do it with a windowing, right? You can render millions of rows. It's ridiculous. Now, before I said that you should put all your props here as individuals on here, right? And that's a little optimistic. A lot of times, you're kind of just at work and you just want to get work done and you don't have time for this shit, which is fair. So you're going to have times where you're not able to just destructure the object down, right? So you're going to have a problem with pure component. And that problem is nested object data, because it only does a shallow comparison of those objects. If you make an update kind of deeply in it, it's not going to know because the top level object is still referentially equivalent, right? And here's how you fix that. There's a lot of different ways to fix that, but I'm going to make this. I'm going to put my stamp on this. This is a library called Immer, right? The MobX guy wrote this. Lovely guy. Really, from the Netherlands. Fantastic. But But really what it does is it creates immutable data structures for you here. And the way that it works is it's immutable by mutating it. And I know that sounds kind of bananas, but you say next state is produce, right? And then you have the initial state. And then you have this draft state. The draft state is the thing that you actually mutate, right? So in here, right, you're going to leave base state alone. Draft state is the functional argument, right? Down here, I'm going to say like draft state, push to do, et cetera, and then this next state has, structural sharing. It's the jam if you're going to have deeply nested objects and you have to work with them. So yeah, use referentially equivalent stuff. Use pure components. Definitely go home and check out this hook shit because that's crazy. And just keep performance in mind. Thank you. Which one? I don't have a website. Oh, like my, yeah, I'll just back that up and keep it on screen in case you're going to give it to, aren't you? Yeah, it's right there. I'm not allowed to publicly disclose where I work, but if anybody wants to ask me when I'm not being recorded, we're hiring so we can talk. It's not like a super secretive place. I'm just have a sketchy public presence. So. Curious about the what was it? Something equivalence? Referential. Yeah.
When you're doing a function inside a stateless functional component, for example, even if it's not the thing inside the thing being returned, is that still not referentially equivalent? Like, do you need to fully pull it out of the functional component?
Yes and no. I mean, if you're defining it inside of the functional component, it doesn't really matter because it's memoizing that as a function. Right? A functional component is just a function, and the memoization works by saying if the same arguments come into it, then give back the cached result as a result of those arguments. So as long as there's not a side effect involved, then creating an anonymous function inside of the function body shouldn't be a problem. So you can bind in the constructor for this binding, but not always for the value binding. So that specific one, we had to use the post ID for the click argument there.
Second, we still have time, so if you like to network, to ask more questions, feel free to do it. Grab as much as food as you can before you leave the building, because it's
We have to leave by
we have to leave by 8:50, so we've got about 20 minutes if you want. Thank you.
So,